Imagine you are a Royal Air Force pilot in 1944. Your Spitfire is the finest piston engine fighter ever built. You have 1,400 horsepower behind you, a top speed of 440 miles per hour, and years of combat experience. Then, from out of nowhere, something screams past you at nearly 550 miles per hour. No propeller, no piston clatter, just a banshee shriek and a blur of silver metal. You've just met the jet age. In today's video, we are going through all of them. So starting with Frank Whittle's WU, this is where it all begins. Frank Whittle, a RAF cadet who could not afford a car, patented a jet engine in 1930. Nobody believed him. The Air Ministry passed. Private investors dithered. But in a drafty shed in Rugby on April 12, 1937, his WU engine ran under its own power for the first time. The sound was described as a rising scream. One terrified observer ran out of the building, thinking it was going to explode. Next is Powerjet's W1. The W1 was Whittle's first flight-rated engine. Britain became the first country to fly a jet-powered aircraft in a sustained, controlled flight. The pilot, Jerry Sayer, reportedly grinned for 3 days straight. The engine made 860 pounds of thrust. Next one is Powerjet's W2B. The W2B was the engine Whittle wanted to put into production. Rolls-Royce and de Havilland were both handed copies of the design to manufacture. What happened next is one of the great industrial dramas of the war. Then comes Rolls-Royce Welland, Gloster Meteor Mark I. The Welland was the production-ready descendant of Whittle's W2B, and it powered the world's first operational Allied jet fighter. Its first combat missions were not against the Luftwaffe, but against V-1 flying bombs over southern England, tipping their wings to send them spinning. The Welland was reliable, if not spectacular. Another one is Rolls-Royce Derwent 1, an immediate upgrade over the Welland. The Derwent gave the Meteor real combat capability. Meteor 3s equipped with Derwents deployed to the continent in early 1945, becoming the only Allied jet to see operational service over occupied Europe. Next is de Havilland H1 Goblin. Frank Halford's Goblin was a rival centrifugal flow design developed independently of Whittle. It was cleaner, simpler, and slightly more powerful. It powered the de Havilland Vampire, a twin-boom jet fighter that looked like science fiction. Another one is General Electric 1A, one of the most consequential technology transfers in aviation history. A fake propeller was bolted to the nose when it wasn't flying to fool prying eyes. Witnesses from the base thought the pilot had lost his propeller and was somehow still flying. Then comes Allison J33. The J33 was America's first high-performance jet engine, developed by Allison, a GM subsidiary, from the de Havilland Goblin design. The J33 would go on to power America's first jet ace victories, in Korea, not Germany. Next is Junkers Jumo 004A. The Jumo 004 is arguably the most important jet engine of World War II. Germany was running short of strategic materials, nickel, chromium, and cobalt. The metals needed for heat-resistant turbine blades were almost gone. The result was an engine that worked, barely, temperamentally, and catastrophically if you throttled it too fast. But it worked. Next is Junkers Jumo 004B-1. The production Jumo 004B was the beating heart of the Me-262, the world's first operational jet fighter. The engine had an 80-hour overhaul life. The aircraft was effectively defenseless because abrupt throttle movement killed engines. The Jumo 004 was brilliant, flawed, and genuinely terrifying in the air. Another comes BMW 003A. BMW's competing axial flow jet was lighter than the Jumo 004 and slightly less powerful. It barely saw combat before the Reich collapsed. Next is Heinkel HES-3B. Here is a genuine world first. On August 27, 1939, 5 days before Germany invaded Poland, this was the absolute first flight of a jet-propelled aircraft in history. Next comes Heinkel HES-8A. It could outrun everything in the sky. Heinkel pleaded with the Luftwaffe to put it into production. The Luftwaffe said no, preferring to wait for the Me-262. It was one of the most consequential bureaucratic decisions of the war. Another one is BMW 003E-1. The improved 003E saw limited operational use in the final weeks of the war. It flew reconnaissance missions over Britain that RAF controllers could track on radar but simply could not catch. The future had arrived, and it was painted in Luftwaffe markings. Next is Heinkel HES-011. The HES-011 was Germany's most advanced jet engine to reach prototype stage, a mixed-flow design that was ahead of anything the Allies had in development. Next is Walter HWK-509A. Technically a rocket motor rather than a jet engine, it powered the most terrifying aircraft of World War II, two liquids that ignite explosively on contact. The Comet could climb to 30,000 feet in under 3 minutes and reach 596 miles per hour. Now this Argus AS-014 pulse jet, it was not a turbojet, but a weapon that changed the face of warfare. The Argus operated on a brutally simple cycle: spring-loaded intake flaps, fuel injection, explosion, thrust, flaps blow open, and repeat. Next is Campini Caproni CC-2 motorjet. On August 28, 1940, the Italian Campini Caproni N1 became the second aircraft in history to fly under jet power, though strictly speaking, it was a motorjet, using a piston engine to drive a compressor rather than a true turbine. Next is Rolls-Royce Nini RN1. The Nini was the most powerful British jet engine of the war era. When the Attlee government sold Nini engines to the Soviet Union in 1946, over the strenuous objections of the RAF, Soviet engineers reverse-engineered it into the Klimov RD-45 and RD-45F. Now this is Jumo 004C, the final planned production variant of the Jumo 004 series, never reached mass production, but test examples showed significant improvements in reliability. Germany managed to produce this engine in quantity in 1944 instead of 1945. Next is BMW 003R. Germany's answer to its own lack of thrust was elegantly brutal. Bolt a Walter rocket booster onto the back of a BMW 003 jet and fire both simultaneously for takeoff and combat acceleration. Development was ongoing at war's end. Next is General Electric J-35. It didn't power any World War II combat aircraft, but was running on test stands before VE Day. Now this is Pratt & Whitney J-42. When America needed a jet engine for its first carrier-based jet fighters, the fastest solution was to license the British Nene from Rolls-Royce. The irony is exquisite. America had given Britain the core jet technology via the GE Whittle transfer in 1941. Britain developed it into the Nene. America then licensed it back. Now this is Heinkel HES-1. Hans von Ohain's first working prototype ran in September 1937, mere months after Whittle's WU. Where Whittle used hydrogen on his first run, von Ohain wisely used gaseous hydrogen to avoid fuel system complications. Next is Heinkel HES-6. It featured improved combustion and compressor efficiency and ran long enough to give Heinkel confidence to proceed with jet aircraft development. Aichi NE-20. Japan's desperate entry into the jet age came in the form of the NE-20, a small axial flow turbojet developed with partial reference to captured BMW 003 documentation. It powered the Nakajima Kika, Japan's equivalent of the ME-262, a twin-engine attack jet that first flew on August 7, 1945, one day after the Hiroshima bomb and 2 before Nagasaki. Next is Ishikawajima NE-130. The NE-130 was Japan's most ambitious wartime jet project, an axial flow engine designed to power a serious combat aircraft. Development was hampered by Japan's limited metallurgical industry, which could not reliably produce the high-temperature alloys needed for turbine blades. Next is BMW 003A. This aircraft flew the last Luftwaffe reconnaissance mission over Britain, photographed the Remagen Bridge before and after it was captured, and executed the only serious attempt to destroy the bridge in the world's first jet bombing raid in history in March 1945. Next is Jumo 004. Thanks to Hitler's intervention, It carried two 250-kilogram bombs in a crude external mount and flew at such high speed that conventional bomb sights couldn't be used accurately. The pilots hated it because the bombs mostly missed. Next is Lyulka VDR-2. Arkhip Lyulka, the Soviet Union's jet engine pioneer, began working on a turbojet design in 1939, independently of both Whittle and von Ohain. He was shut down when Germany invaded in 1941. He restarted development in 1943, but it was too late and too underpowered to influence the war. Next is Klimov RD-20. At war's end, Soviet teams swept through Germany's aviation factories and laboratories, seizing engines, blueprints, and entire engineering teams. Next is Powerjet's WW2 700, a high-compression variant of Whittle's W2 series. The WW2 700 showed what centrifugal turbojets were capable of when properly refined. It never entered production. Rolls-Royce's versions had taken over by this point. Next is de Havilland H2 Ghost. The Ghost was Halford's follow-up to the Goblin and showed the rapid pace of British centrifugal jet development. Running on a test stand before war's end, it would go on to power the Comet. Next is Armstrong-Siddeley ASX. Armstrong-Siddeley entered the jet race with the ASX, a centrifugal design that competed internally with the Whittle-derived Powerjets and Rolls-Royce engines. World War II was Britain's jet engine university, and Armstrong-Siddeley was among its most diligent students. Next is Metropolitan Vickers F2. Metrovic's F2 was the most advanced British jet engine of the war, an axial flow design that produced thrust numbers comparable to the Welland, but in a slimmer, more aerodynamic package. The government chose the centrifugal Welland for production instead because the axial engines being considered too risky. Next is Heinkel HES-30, a refined centrifugal flow engine that Heinkel developed as a backup to von Ohain's axial designs. The HES-30 program illustrated one of Germany's core problems: too many competing jet projects, insufficient industrial focus, and no senior champion in the Luftwaffe command willing to break the impasse and pick a winner. Next is Focke-Wulf TA-183. Kurt Tank's swept-wing TA-183 was Germany's most advanced jet fighter design, a single-engine aircraft with a 40-degree swept wing that would have been powered by the HES-011. Wind tunnel tests were complete. The jig for the first prototype was being built when the Allies arrived. Heinkel HE-162. If the ME-262 was Germany's thoroughbred, the HE-162 Volksjager was its scrappy terrier. Designed in 90 days, built largely from wood and sheet metal because aluminium was scarce, it was a product of desperation given wings. Next is Junkers Jumo 004. Before the BMW 003 version, the standard AR-234B ran on two Jumo 004Bs. This aircraft holds a specific historical distinction. On July 25, 1944, an AR-234 prototype flew the world's first reconnaissance mission by a jet aircraft over the Normandy beaches just weeks after D-Day. Next is General Electric TG-100, an early American attempt at a turboprop, a jet engine whose output is used to drive a propeller via a gearbox rather than produce pure thrust. The T-31 was genuinely innovative and pointed toward the turboprop era that would dominate post-war transport aviation. Westinghouse J-30. Westinghouse was the American company that independently developed an axial flow turbojet without using Whittle's centrifugal technology. The J-30 was small, light, and clever. The J-30 didn't fight in World War II, but its development ran throughout the war years. Next is Wright Aeronautical. The lineage here matters. The J-65 was a licensed American production of the Armstrong-Siddeley Sapphire, which was itself the direct descendant of Armstrong-Siddeley's wartime axial flow research. Next is Nakajima NE-130. Nakajima also worked on the larger NE-130 axial flow engine, intended for heavier aircraft. The program suffered from Japan's inability to machine precision turbine components at scale, a problem the Germans had partially solved with hollow sheet metal blades, but which Japan could not replicate quickly enough. And finally, the last one, General Electric J-47. The J-47 was developed directly from GE's wartime J-35. Every kill that Sabre scored in Korean skies was won by technology whose family tree ran back through Lynn, Massachusetts and Rugby. Thank you for watching, and see you in the next amazing episode.